name, we got three components. We got scan name, scan IP address, scan listener. And behind the scan name, we got all of them IP addresses running behind this scan name. This IP address is running to the DNS server that's administered for the network team. And the scan name, the scan IP address, and the scan listener is supposed, no, the scan listener is the scan IP address is supposed to be the same. Like if you got by default it's three IP, and you have to have three scan listener. Okay. But the scan listener is contacting load balancer advisor for know the balances running to the nodes. But you mentioned about the, oh my God, I forget my question. You mentioned about the
Fali, you are muted. Did you mute yourself or is it a mistake?
I'm so sorry. I'm making a mistake. You mentioned about it. I'm sorry, Mr. Gata. We'll take your time. I forget the name.
Take your time. Take your time. No worries.
Yeah, I'll look you one up. I'll put that name. Sorry, Mr. Gata, just 20 seconds. I'll go. Oh, you mentioned about domain name. That's making me confused if the domain name is the scan IP address or the domain name is the component the network team is created by, it created for all of them component the scan name. That's making me confused. The domain name, I don't understand that domain name. That's what making me confused.
No, you see some places that you say that the scan name is the domain name, right? Is the domain name. So you can create a domain, like you say, okay, you have a domain brontechsolution.com. It means that all component, you know, at some point we have, okay, in their name, right? They have brontechsolution.com. Like you guys can notice that on your private IP addresses, public IP, virtual, anything, the name, somewhere the brontechsolutions.com, right? So that domain name that's what we can call a domain name, and it's something you can create. That's something the network team can create. Okay, so don't take it like it's very, like something very complex. Okay, so we have a domain name, and we use that domain name now in order to create, other components name. So the domain name can be part of the virtual IP, can be part of the public IP name, it can be part of the host name, it can be part of the scan name as well. That's why if you guys pay attention to your scan name, the one you guys use to configure RAC, somewhere there's also brontechsolution.com. I'm just taking an example, right?
Yes,
as what can be a domain name. Okay, so domain name is just part of the name of a component that has an IP address. Because whenever you want to resolve a name using a GNA server, you need, whenever you need to map a name with an IP address, okay, that name now, you can include a domain name on that, okay? So that name can be made up of a domain name plus something. That's what makes the difference between all the components.
Okay, thank you so much. My second question is, you say, well, not last class, I think before the last class, you talk about the two types of the nodes. We got the dedicated server and the server pool. And you say, my question is, the dedicated server, you can use the scan, or the dedicated server not use the scan?
For all of them, you can use scan. All of them. Okay, for both dedicated, you are talking about administrative managed and policy managed database, or dedicated server and server pool? Yeah,
because you said the administration database is wanting to do dedicated server, and the policy database is wanting to server pool. That's my question, is because you said that dedicate, we got all of our three to do server like it was before, well, now we got scan name. Behind the scan name, you got every IP address you're running. But you said that the dedicated server, we put all of them, the server, all of the nodes running and the TNS name. That's my question as well. Think about if we.
Oh, okay. I'm trying to understand what you're saying. So, first of all, when I was talking about administrative managed database, that is what we'll be doing today. But just to say that, that database, you are going to choose some dedicated nodes, some dedicated server in which you want the database to run on. Assuming that, for instance, you have 4 servers, class 1, class 2, class 3. Let's take 4 servers, server 1, server 2, server 3, server 4. Administrative managed, you can say that, okay, you want this database to run only on server 1 and server 2. It means that the database will run only on that. So you can choose in which server you want the database to run on. And even in that scenario, you can use a scan. That means if the scan is configured, the scan now will help to manage connections, okay? Connection in the entire cluster. Because the scan is a component for the grid infrastructure. So what does it mean? It means that the scan comes whenever after you configure the grid infrastructure. So it doesn't depend on the database. It doesn't depend on the type of database, whether it is policy managed or administrative managed. It doesn't depend on that. It is something that is configured at the cluster level. So that means when you configure the grid infrastructure, if you configure the grid infrastructure for 4 nodes, it means that the scan with the IP addresses, right? We do 3 IP addresses, will monitor all the 4 nodes. At this point, we have not yet decided whether we are dealing with policy or administrative managed. No. So this is the first thing you should know. Okay. So the scan runs at the server level. It doesn't run at the database level or an instance level. So okay. Now that you have 4 servers that are configured, you install the grid infrastructure on them. Okay. Now when you create a database, you say, okay, you want an administrative database, and you want the database to run maybe on 2 of the servers instead of 4. You want the database to run maybe on 2 of them. The scan will still help to manage connections on those 2 nodes. So it means that if the database instance, right, the database runs on node 1 and node 2, the scan will make sure that there's a load balancing on node 1 and node 2 for that particular database. If it's a server pool, if it's a policy managed means that you are going to create a server pool. That means there's a server pool attached to that. So
yes,
scan will also help to manage connection in the entire pool. So it means a database created for a particular pool of 3 nodes. The scan will help to balance the load on that pool. So the load will be balanced in those 3 nodes. I don't know if it makes sense or not. Just let me know.
No, it makes sense. Thank you. You explained my next question. I don't have no question anymore. Thank you.
Okay, no problem. Thank you for your questions. Okay. Any other question for me?
Yes, sir, of course, I have a question.
Yes.
Okay, so we ran into an issue yesterday where we actually partitioned Dix1 for when we were installing a great software, a great infrastructure. So we actually just partitioned grid 1 like how the guy did on the video. So it ran, and when it got to the point where we needed to run that script, connect to root and run a certain script. So we did everything on RAC 1. We went now on RAC 2. We discovered that the Dix1 we choose, it shows a message that it has been chosen by ASM and it failed. So I don't know whether if you choose a particular Dix for OCR, it's gonna reside only on one server or it's not gonna reside on the other server.
I'm trying to get your question. So you got into this issue after the grid infrastructure installation, or at what level?
During, you know, when it will run and it got to like 80 something, and now it will direct you to run the script, right?
Okay, when you are inside the grid infrastructure.
Right. So during.
Okay. Yes. Mm-hmm. At the end, right? You run 2 scripts, right? I think
right,
2 scripts.
Right, exactly.
On both nodes. If you run on both nodes.
On both nodes. So my question now is, I don't know whether the Dix we choose, we actually choose Dix1, whether the Dix we choose, it would reside only on RAC 1, all on node 1. It won't reside on the other node, because on the other node, it was giving us an error message that Dix, a particular Dix has been chosen for ASM.
Okay. You know, in order for me to say something, I have to understand what you guys have been performing. So, do you set up SSH between the node?
Right, we set up SSH, we took a picture, and we're very happy that we you know, so it was even connecting, we tested, everything was good.
Okay. So, and when you were creating the OCR this group, that is when you choose that disk number 1, correct?
Exactly.
And when you get to the end, when you come to run the scripts,
yes,
it's telling you that the disk is already used by ASM.
Right. On the other node, but for the node 1, it was good.
Why are you on the other node?
Because I had run it on node 1, it was good. Now I had to run it on node 2.
Run what? The script?
Yes, the script.
Okay. Do you run in order? Because sometimes it asks you to run on the second before the first, and something like that.
Right. We did it in order.
Okay. On the pre-check, was okay, or would you have a warning there?
Okay, now, so we later discovered that the Dix, we had to partition the Dix. So the Dix, we first of all did it, and it didn't partition. So the Dix didn't create. And it was later we discovered, we went out to the part we discovered, and then we ran the script, and now it shows the error that the Dix1 has been chosen for ASM.
Okay, and which script do you run again for the partition? Initial ASM setup?
Right, that initial ASM setup, yes.
And what do you run on the other node?
We did basically almost the same thing, like we followed the steps, but we didn't verify if the Dix had been created before we did the run installer.
But when you run the initial ASM setup on node 1, on node 2, what do you run?
So yeah, we ran the same thing.
No. Are you sure you run the same script, initial ASM setup on node 2?
Yes, sir, we did.
No. if you watch a video carefully, you should not run initial ASM setup on node 2 as well. You should run the other one, order underscore setup something.
Exactly.
So I think that was where the conflict, we had a conflict.
Yes, because the disks are created once. The disks are not created twice. So you create a disk only from one of the nodes. And the other node is just to scan and to link node 1 and node 2. So you should not run initial ASN setup twice. Because if you open the script, you will see that the initial ASN setup partitions the disk, but the other node something doesn't partition the disk. It just scan the disk, initialize the ASM, and so on.
Yes,
So
so
you were trying to run the same thing twice. That's why you will see that error.
So we actually did that to see if we will fix. That's why we reran it. Because initially I remember we went to the space, we checked, it wasn't there. So that was why we thought probably we didn't run it. That was why we still ran it again.
So so that means now and so do you try to run the other thing later on?
So at that point, buffer cache was already full. So
why you could have tried, right? You could have tried to to run it again. To now that you knew that you failed in running the initial ESN setup on node 2, you could have just run the other node setup there and proceed. Because what happened is after you went all the way to the grid infrastructure configuration that the error popped up again, but it could have been resolved before even calling the uninstaller.
yeah.
Okay, so I think that is where the mistake is coming from. I never got into that issue. Okay, I never got into that issue. We faced it, but I don't know. We ran the script again, other node setup immediately. We did not go all the way to the grid infrastructure configuration before facing the same error again.
So we just
What do you want to do now?
we just reset the server. We're gonna do it tonight.
Yeah, it's fine. Just reset it. How many servers do you have, Mr. Koji?
We have just one. So you gave us just one.
Because yeah, you guys are few, right? Just few members, so it's normal to have few servers as well. I think your group you are less than 5. So and based on allocation, you deserve less servers, of course. Okay. So yeah, I think you guys can, yes, the reset. You can try it tonight. Pope already clean up the servers.
Our class servers?
Yes, your server. As soon as you want it to be clean, you have to forward it to him, right?
Oh. Yeah.
What do you think? It should be clean. So if you want Pope to clean the server, sometimes some other way to, I don't know if the formula has changed, but at the group level, the group leader could just send the server. Okay, at the group level. So you can just forward your server, and as soon as you send it, most of the time, it has less than 2 hours, right? You have less than 2 hours to, sometimes less than 3 hours to clean up your server. So yeah, you guys can reach out to him, and he will resolve the issue for you.
So sir, why are we cleaning our class servers? I thought we were working on the RAC.
I'm talking about the RAC server, not your class server. If I say class is RAC, it's RAC. It's not your class server. Okay? Yeah, it's RAC. Okay. Any other question for me? Any other concern?
Yes, I have one last question.
Sure, please go ahead.
So you were trying to, you explained actually last class how connection is being done on a RAC environment. And
Okay.
and let me try to see if I can give a brief summary, and then I ask my question. So you said database to connect on a database, the application will have to connect on a database service, and the database service would therefore go now to the scan listener. So excuse me, I have to postpone the question. I have noise on my background.
It's okay. No worries. Okay. Another question for me before we proceed? Any other question? Okay, let me share my screen then, and we take 15 minutes or 20, depending on how many questions you guys will have, to round up this PowerPoint. I will not cover everything. I will just cover what I find useful. Okay, before we proceed. So, as a quick reminder, last class we talked about ASM. Okay, I introduced ASM, right? And I said that I don't like this mouse. I don't like this mouse. Anyway, let me see. Okay, so we introduced ASM and we explained some, some benefit of ASM. And I said that the regular ASM, right? With the regular ASM, the ASM will run on each node, okay? So the ASM is like the mediator, right? It's what we allow database instances to access the storage. So moving forward, a database instance, before you go to the storage, you actually reach out to the ASM instance, and then you go to the storage. And we said that the ASM instance is a volume manager, and it's the storage manager, right? It stands for automatic storage management, and it has multiple benefits, multiple advantages. And some of them, we explained the concept of striping. And we say that striping means that if we have a disk group is made up of disk, right? Made up of one or more disks. So striping means that if I have a disk group for data file, right? A disk group named data. And that disk group has maybe 3 disks. When the data is getting to that disk group, it is split equally, right? Among the existing disk on the disk group. So, and the example I took was that if the data going to the disk is 10 megabytes in size, and you have 3 disks, just take the 10 megabyte and divide by 3. So each disk will have 1/3, right? 1/3 of the data. So it means that the data found on this 1 will be different from the data found on this 2, will be different from the data found on this 3, right? Because because of striping, right? So that was what we explained when we were coming to striping. And the striping is also to make sure that the load the data is balanced at the disk level. So we have the same amount of data on each disk. Okay. So we don't want one disk to have more data than the other one. Does that make sense? So ASM will take care of that. Make sure that when the data is getting to the storage, the striping process will take place. And further, we explained the concept of redundancy. Okay. And we said that we have 3 types of redundancy. We have external, we have normal, we have high. You should be able to explain those 3 in an interview. It's mandatory, it's not an option. So especially redundancy, that is mandatory. So, and I say that external redundancy just means that the data on each disk, right, do not have any copy elsewhere. So it means if I have data on this one, there's no additional copy of that data, right? So that copy is unique. Same thing for disk 2, same thing for disk 3. That is caused by the striping, right? So the data is unique on each disk. The only copy you may have is only if the backup are taken, right? Whenever you have an RMAN backup, everything is backed up and is stored in a different disk group called plus FRA. But in that particular disk group, the data on each disk will be unique. No additional copy somewhere else. That is external, unique copies, no mirror copy. Okay? And we talk about the second type of redundancy, which is normal. And we say that normal, it just means one additional copy. And we say that we have two scenarios, without failure groups and with failure groups. Without failure groups just meant that one disk will store the copy of the other disk, right? And I took the example with this image explaining the colors, right? And I said that each disk will keep the copy of the data of another disk. For instance, if the data on this one is in green color, right? Its copy will be stored on disk 2, for instance. So that means the backup of one additional copy is stored on a different disk. Same thing, if the data on disk 2 is maybe the black color, the copy of that data is stored on a different disk. If the data on disk 3 is a red color, the copy of the data is stored on a different disk. So each disk will store the copy of, the copy of another disk. So the data, each disk will store the data of another disk. That's basically how I can explain it. Okay, this is without failure groups. So if you go to this one will have its own data plus the data of another disk. Okay, and this will help in case of failure, right? If I lose this one, I know that whatever is found on this one, whatever I have on this one is found on a different disk. Okay, you can see here, for instance, if I lose this one, the red color is also found on disk 3. That means my data is reachable through disk 3. If I lose, the green color will be lost, right? But I have a copy on disk 2. So that will help to avoid single point of failure, definitely, okay? So that is what normal is without failure groups. But with failure group, I say that instead of allowing one disk to keep the copy of another disk, instead, you are going to configure separate disk, right? Separate disk to store the copy of the data. So it means that now the copy of this one will be stored on a different disk than these 3, right? Out of this disk group. So the copy of this one, for instance, could be stored on disk 4. The copy on disk 2 could be stored on disk 5, and the copy on disk 3 could be stored on disk 6, for instance. So a different set of disks will store the data of this individual disk. That is if you want to configure failure groups, okay? And failure groups, again, have that advantage of it has multiple benefits, but it also involves more expenses, right? Simply because if you see you have to configure new disk, you have to make new disks available, okay? And that is money, right? Storage is money, definitely. So, and the same procedure, the same concept is valid for high redundancy. So instead of having just one copy of the data found on a different disk, you have now 2 copies, right? So it means that disk 1, you have 2 additional copies, right? Maybe one will be stored on disk 2 and another one will be stored on disk 3 and vice versa, to avoid, again, single point of failure. So that means normal redundancy can tolerate the loss of one disk, while high redundancy can tolerate the loss of 2 disks. Normal redundancy can tolerate the loss of 1 disk. High redundancy can tolerate the loss of 2 disks. Why am I saying that? If I lose this one, I can still get the data somewhere. I can still get all the data, all its data either on this 2 or this 3, correct?
Correct.
Everything on this one, right? The green color is also on this 3, 2. The red color is on this 3. That means if I lose this, right? At least I can get my data through this 2 or through this 3. But if I lose this 1 and this 2, I lose data, right? I lose which one? The green one. If I lose this 1 and this 2, the green one will totally lose it because there is no copy of that on this 3. Does it make sense? So in this scenario, I'm saying that normal redundancy can tolerate the loss of only one disk. Is it clear or not?
Yeah, it's clear to me.
So that is the same thing for high, right? High redundancy can tolerate the loss of 2. So you apply the same concept, you will see that you can tolerate the loss of 2 disks with high redundancy. So that is what I explained when it comes to redundancy. And those copy are called mirror copy. So, okay. So if people say two-way mirroring, three-way mirroring, is the same thing. Okay. So most of the time for normal redundancy, we talk about two-way mirroring because you have one additional copy. And for high redundancy, we talk about three-way mirroring because you have at least two additional copies. Okay. So that is how redundancy works with failure groups or without failure groups. And also ASM provides other benefits like talk about swiping, talk about mirroring, also rebalancing, okay? Automatic rebalancing. What does it mean? What does rebalancing mean? Actually, it's on this PowerPoint. I'm not getting it from anywhere else. Rebalancing, dynamic online storage configuration and dynamic rebalancing. What does it mean? It means that, let's assume you are running out of space, right? The disks in the disk group are full. What do you need to do? You just need to add new disks, right? Add new disks to the disk group. So by adding a disk to the disk group, that disk will be empty. It won't have any data. So rebalancing means what? Automatically, the ASM is going to balance, the data across all the disks. So those disks that already have some data, right? We get some of their data and share with the one that do not have any data. That does not have any data. Okay. So taking an example of, I have a disk group, right? That has 2 disks. Each of them have 10 gigabytes of data. I add a third disk, right? That has 0 data. Because other disks have 10 gigabytes, the new one has 0. There's no balance, right? It's not balanced. So the ASM will take care of the load the dynamic rebalancing. So ASM will grab some data from this 1 and some data from this 2 and put the data on this 3 so that they have almost the same size. So if I make a small calculation, right? 10 plus 10, let's assume that this one has 10 gigabytes, this 2 has 10 gigabytes. 10 plus 10 makes 20, right? If now I divide it by the 3 disks, how is it? It makes 6.666. Okay, so it means that each disk will have around 6.6 gigabytes of data. Okay, so they have almost the same amount of data. So the ASM will take care of the balancing. So the disk that you added, automatically ASM will get data from other disks that are already populated and we populate the new disk. Okay, so that they have almost the same amount of data. Same scenario is applicable whenever you are removing a disk from a disk group. So you are removing, if a disk group has, for instance, 4 disks or 3 disks, you are removing one of the disks. While that disk is leaving, it will share its data with the surviving disk, with the remaining one. So if that is had maybe, if that disk that you are removing, right, had maybe 4 gigabytes of data, and you have 2 disks that are left, you will divide those 4 gigabytes by 2. 2 gigabytes will go to the one of the disks, and 2 will go to another disk. So ASM will take care of that. We make sure that the load is balanced at the disk level. Okay. one disk should not have way more data than the other one. It can be a little bit above because we don't have decimals. Okay, when it comes to data, you don't have decimals, right? But it won't be far. You cannot have a disk that has 10 gigabytes, another disk has 5 gigabytes. It's impossible. Maybe the other one will have 10, and the other one will come with 9.5, 9.8. Very close. Okay. So that is what the ASM takes care of. It also takes care of that. And ASM also takes care of detecting a corrupted disk and remove it from the disk group. So whenever a disk is corrupted, right, ASM put it aside. And if you are in an environment that has some monitoring tools, you can receive a ticket about it. Like we do have some monitoring tools to monitor disk on a disk group. Whenever a disk fails or a disk is corrupted, automatically there's a ticket that's created for us, and we have to either replace the disk. Most of the time, what we do is we replace the disk because ASM is no longer using it, right? It's no longer considering that disk. So you just come and remove it from the disk group and add another disk to the disk group. So that is also what ASM is able to do. And yeah, also making sure that the naming convention of the files, ASM can help you, especially when you're using Oracle Managed File. You can give ASM, and ASM will choose the naming convention for your file. Okay. I think you guys are all a bit familiar with Oracle Managed File. When we're on Oracle 12c, I talk about it. You don't have a lot of control over the naming convention of data file. Okay. So when you ASM, you can decide that ASM will take care of the naming convention. Otherwise, you yourself can take care of that. And we create a database today, and we will see where you can decide. So these are just some critical benefits, okay? And it also goes with some important ASM parameters, okay? Some of them look familiar, okay, to you. When the type of instance, because we are talking about ASM instances, so the type of instance is ASM. So this is what you will see on the ASM initialization parameter file, or even the P file, you can see that there. The DB unique name of the ASM, if it's a single instance, you will see plus ASM. But if it's a RAC environment, that means a RAC environment, you have multiple nodes, right? It means that if ASM is running on node 1, you will see plus ASM 1. If it's running on node 2, you will see plus ASM 2, and so on. So that is what makes the uniqueness. And another parameter could be the ASM power limit. And this one is to speed up the rebalancing process I just explained. Okay. So if you want the rebalancing to move faster, you just have to increase the value of ASM power limit. By increasing it, you will speed up the rebalancing process. Okay. And you can monitor it. I think one of the questions of the practice will be to add a disk to a disk group. So when you guys will add it manually to a disk group, to an existing disk group, you guys can check how the rebalancing is taking place. So there are some views that you can query. For instance, we query the VDollar ASM underscore operations, and from there you can see that the rebalancing is taking place. So the ASM is actually taking care of the rebalancing while you are adding a disk to a disk group. Okay, so this is the parameter you need to set up in order to speed up the rebalancing process. And the process that monitors, or the process that coordinates the rebalancing operation, is called RBAL. You guys should know this name. RBAL coordinates it, but RBAL has some slave processes. Those slave processes are the ones to actually do the job, but RBAL is there to coordinate. And you have other parameters, ASM disk group, ASM disk strings. Both of these parameters specify the number of these groups, and the other one you specify, how fast you want a disk to be added to a disk group. Okay, do that here. So you guys should know at least 3 of these parameters whenever you get to an interview. I don't know if I don't like this mouse. I don't know why. Okay, so yeah, I always had it somewhere. Even when I was, since 2019, when I was helping some people get a job, I do that. So yeah, definitely those are some important parameters. You can go online and find additional parameters. Okay.
So I hope you will help me get my own job. Oh.
That's a different topic, right? It has nothing to do with this one. Correct. So that is something else. Talk about it later.
Okay.
So I think that's all I explained about the ASM, the regular ASM. So today we talk about the flex ASM and the flex cluster. That is where I will stop today. It's part of the 12C new features, because it's only on 12C you can have a flex ASM and a flex cluster, 12C and above. Okay, you cannot have it on 11G or 10G. You cannot. Just very only big environment we have this stuff, flex cluster. And let me explain how it works. The flex cluster comes into place whenever you are dealing with a huge number of nodes. We all know that nodes, they have to communicate, right, through the interconnect in order to allow, the cache fusion and other stuff we learn. So, but imagine you have 20 or 50 nodes. I mean, 50 nodes. In 50 nodes, it means that I will have a lot of cable moving around, right? 50 nodes. Node 1 may need a cable with node 2, 3, 4, 5, 6, all the way to node 50. Same thing for node 2, same thing for node 3, same thing for node 4, and so on. So a lot of cable, a lot of interconnect cable moving around. And that will definitely cause overhead, right? A lot of how do we call it? Whenever they are consolidated, right? It can cause, some bottleneck, and it will definitely reduce the performance of the data moving across node. So and that was a huge issue we were facing on 11G. Now Oracle brought out the concept of flex cluster, and now the interconnect is no longer, between all the nodes. Node 1 no longer need to have an interconnect with node 2, node 3, node 4, all the way to node 50. Okay, we can have an interconnect just for a set of nodes, interconnect for another set of nodes, interconnect for another set of nodes. So it means that I will have few cables in this scenario, right? So, and for instance, what will happen is that this will be like a set of nodes. So this set of nodes are communicating, but they are not directly communicating with this set of nodes. And also, they are not directly communicating with this set of nodes. But all of them are sharing the same storage that you can see on this picture. So what does it mean? It means that there's a communication between each of these leaf nodes. They are communicating, they are sharing data. There's a communication between each of these leaf nodes. They are sharing data. Cache fusion can take place. There's a communication between this leaf node. Cache fusion can take place. But there's no communication between this leaf node and this other leaf node. There's no communication between this leaf node and this other leaf node. So, and that is how it works basically. So the communication is just a set. That is like I create a block of cluster. Instead, I split the big cluster into small block, right? So the first block is this block, the second block this block, the third block this block. Okay, so it reduces the communication between nodes. So node on this block do not need to communicate with nodes on this other block. Okay, they are shared, they are communicating, they are just everything happens just among this. Okay, and we call now there's a very important concept. The ASM now doesn't need to run on each of the nodes. So before the type of ASM used in this particular configuration is called ASM flex. It is mandatory to use an ASM flex when you are dealing with flex cluster. Why? What does it mean? What does it mean? It means that a flex ASM, right? As you can hear, the name is flexible. Flex, right? It means that that ASM instance will be able to monitor database instances running on a different node. I told you guys earlier that the normal ASM on each node, right? Each node has a normal ASM, and that ASM monitors only the database instances present on that node. But with the flex ASM, an ASM instance can monitor a database instance running on a different node. It is flexible. So you no longer need a one-to-one relationship between a node and an ASM instance. You can have a multiple nodes managed by only one ASM instance. The example is this next picture. You can say for this example, for instance, right, that ASM3 is an ASM, is a flex instance. And this ASM instance tree is able to monitor RAC3 instance and RAC4, which reside on a different node. Okay, so we no longer need an ASM on every single node. Okay, if I have an ASM running on a particular node and that ASM is a flex ASM, it can monitor instances running on a different node or instances running on that same node. Okay, so that is how it works. So trying to bring that concept of flex ASM to the flex cluster, that's why you can just have a flex ASM on the hub node, which behaves like the parent node. So, and this flex ASM will manage database instances running on all the leaf nodes remotely. Okay, so we no longer need an ASM on each node, on each leaf node. The flex ASM will run only on the hub node. And for any instance to access the storage, each instance here has to go through the flex ASM before it can access the storage. Okay, so that is how it works. I don't know if it makes sense, the concept of flex ASM and flex cluster.
Yes, sir. A sharp question. Do you have to install, like, since on the diagram here, we see the flex ASM is on node 1, right? And is it like the same explanation you're giving on this one applies to the other nodes and the other leaf nodes?
Yes, that means on this hub node as well, there will be another flex ASM to monitor all the leaf node, all the database instances on it, and same thing for the other hub node. So the ASM flex is now running only on the hub node. It's not running on the leaf node. Make sense, guys?
So, sir, normal, basically, if I understand from, basically the reason for the leaf nodes, it's like you have multiple nodes and you don't want like the interconnect. That's why you're using the flex ASM.
The flex
Is
cluster.
that it?
That's why I'm using the flex cluster. Okay, because the flex cluster now you can split them as blocks, form of blocks, right? Now you no longer, all the nodes do not need to communicate. You don't want all the nodes to have to share, you don't need an interconnect cable, right, between all the nodes. Okay, so what happened is that you can just split them, okay, as blocks, right? The first block, they will just communicate, they will just share everything among themselves, right? They just share the interconnect among themselves. The next block, the same thing, the next block, the same thing. But a node on this leaf block, on this block, right? A node here cannot communicate directly with a node on this other leaf node, on this other block. So you are reducing the amount of cable, okay? So the cable now will be just between this leaf node and this hop node, this leaf node and this hop node, this leaf node and this hop node. You no longer need some cable between this leaf node and this leaf node and so on. So it helps to reduce the amount of connectivity, the amount of cable you need to set up a RAC environment. And it makes sense. Does it make sense, Mr. Joe, or still some clarification needed?
Yes, and okay, if that's the case, so please, can you just clarify me on the leaf node section? Like, for example, here we have 4 nodes, for example. So how do they still interconnect, like the leaf nodes among themselves through ping, like is it ping or like to ping themselves to know if like they are connecting to each other?
Exactly. Now they will just ping each other. They will not ping others. They will just ping each other. So the CSSG of the first leaf node will ping the CSSG of the other one and so on.
Oh, so now they no longer interconnect, they ping themselves now.
Yes, they ping themselves, you know. The communication is just among these, it's just between these leaf node now. Okay. It's like now you have a RAC 4 node, for instance. Okay. So the connectivity is just between these 4 nodes now. Okay. You no longer need to check. The CSSD of this node will not check if the CSSD of that node is available or not. Okay. They will just check the CSSD of the node that are part of the same set of leaf nodes. I don't know if it makes sense.
Yeah.
So in this instance, is this a RAC 4 node or a 5 node?
This is just an example, just an image, right?
Yeah.
It's an image. But what happened is that the leaf nodes are connecting, discussing with each other, right? And also they have a connectivity, they can connect to the hop node. Okay. So the ping is also valid at the hop node level. So the CSS of this hop node will also ping whatever is on the leaf node to make sure that a leaf node is available. Okay. So the node eviction will take place at this level, at this block level. Okay. So what do I mean by that? It means that this block we not check if this other block is available or not, if this other block is responding or not. They just take care of themselves. Okay, so this entire block, this is where the cluster where there's cluster where the CSSD should run. We should make sure that the other node is available or is not available. Okay, so now everything is splitted. Okay, it's no longer global, but we created some blocks. So a chunk of cluster, one set of cluster for the first hop node, another set of cluster for the second hop node, and so on.
Mr.
Yeah.
Gata,
Yes, sir.
just a little clarification. We know and each node, the cluster synchronization service demos running each node as it communicate. You say here we got the hope node, like the flat one is making communication between like 4 nodes, the part 1, and the flat node, we got the communication, maybe the flat node, no communication to, no, the host node 1 is communication to host node 2 or not?
They're not communicating. Hop node 1 and hop node 2, they do not have anything to share. If you can see here, there's no link, nothing links there. They just have a common storage, right? So the
Yes.
CSSD, as I said, right, will be running on each node. So now they will try to check each other just on this particular block. So it means that the CSSD of node, let's assume that the first block, the first rectangle here, right, is node 1. The second one is node 2. The third one is node 3. The fourth one is node 4. The CSSD of node 1 now, we check, we ping the CSSD of node 2, node 3, and node 4, and vice versa. So each leaf node will just try to verify the existence of another leaf node, okay, that reside on the same, that's part of the same hub node. Okay, so they will just check each other. So the cluster-wide communication, CSSD, whatever we discuss about, will just be at the leaf node level. And also the leaf node will also try to check if the hub node is also available. So they communicate among themselves and they also communicate with their hub node. But what I want you guys to understand is that a leaf node, that's part of this particular hub node, right? We
Yes.
never communicate with another leaf node running on a different hub node. It's like this one as a child, this one is the parent. Okay?
Yes.
This parent had
Yes.
this child, this parent had this child. This child will never talk to each other, but this child are communicating. They're talking to each other because they are they have the same parent. They share the same parent. I don't know if it makes sense.
It makes sense, Mr. Gata. My problem is, my question is, if for example, the hub node 1, all of them go down, but maybe all of them nodes, the product database is running for all of the nodes. But if the hub node 2 is go down, if it's not communicate, why is it go maybe send the poison to kill them to, if we got slap brain for the flat one, then the hub node 1 and the hub node 2, we got slap brain. What go happen?
No, definitely no, hub node 1 and hub node 2 are not communicating. So definitely there is no relationship between them. You can just see that they just have a common storage, right? But you don't see any line here, right? So that they are independent. And coming to the example of if hub node 1 goes down, okay, that is another big danger. If this hub node is a node, so if it crashes, all the leaf node will also crash.
Yes.
Unless you created database services and you enable transparent application failover. That is what makes it also interesting, because you can create a service. You see that the service, the primary node will be this a leaf node here, and the failover node will be a different leaf node. So in that scenario, if this hub node fails, that all the leaf node will fail, but the service, because the service had because it enabled transparent application failover, right, at the service level, that service will move from here to the other one. So it will run to the surviving hub node. Okay, so definitely when you lose a hub node, definitely all the leaf node also will be lost, because this leaf node have to go through the hub node in order to access the storage. You don't see any line here that goes straight from here to here, from the leaf node to the storage. No, they go first, they should reach out to the hub node, because that is where the ASM flex instance is running, and now they can now go to the storage. So if the mediator is no longer there, they will also fail unless you enable TAF, so that the services will move from this node to the surviving leaf node. Okay, but they're different.
Okay, Mr. Gata, you say we go have one and the RAC, we got one what do you call it? the big buffer, the big who
The global buffer cache.
the global, yeah, thank you, the global buffer cache who make the communication between the nodes for the, if the nodes to hope, the hope node one is looking for one block, that block located, the master block is in hope node 2, but what can be the communication for that case?
And this scenario, the global buffer cache, right, will be between
Yes.
the leaf node and the hop node. Okay. So the global buffer cache, that
Okay.
means the block can move across the leaf node and also between the leaf node and the hop node only. So
Okay.
the block cannot go out of this seeker.
Okay.
And it makes sense.
Thanks. It makes sense. It makes sense.
Can you, I didn't quite understand what Fadi was saying.
We were talking about, you were trying to relate it with the global resource directory I explained, right? And
Okay.
earlier I said that the global resource directory is like the global, we have now a global buffer cache, right? A shared buffer cache from where, if instance 2 need a block, it will go there and check where the block is located and which instance owns that block, right? I think that is what I explained about the global buffer cache. So, and he was trying to understand how, he was trying to relate that, right, with this flex cluster configuration. And that's what I was telling him, that now the global resource directory will be between the hub node and its leaf node only. Okay, you will not have the global resource directory between hub node 1 and hub node 2. They are not communicating. Okay, so the global resource directory now is between this hub node and its leaf node. So if I have an instance that's running on one of the leaf nodes, and that instance is looking for a block, you will check it only on the surviving leaf node or the hop node only. Okay, you will not check it on another leaf node. Okay, you will check it only among the existing one here, and you can also check it on the hop node. Does it make sense, Ms. Anita?
Yeah, it does. Thank you.
If it doesn't make sense, just let me know. Okay.
Yeah,
So,
it makes sense.
So, sir,
Okay.
sir,
yes.
I don't know how. So, how many cluster would you call this? Are there 3 cluster or just 1?
Man, I'll just call it a flex cluster. The name is up to you, right? I don't know which name do you want to give.
No, I'm saying like it, like the whole like the whole diagram. Would you call it just 1 cluster?
It is a cluster, but the type of cluster is a flex cluster. This is 1 cluster.
Really?
This is 1 cluster, but the type of cluster now is a flex cluster, because it's like a 1 big cluster, but now you have sub clusters behind, right? That like sub cluster, because this one is forming like 1 sub cluster, this one like another sub cluster, this one like another sub cluster. But if you want to identify, it's 1 cluster, because 1 cluster wants to share storage, right? So, but if you are trying to talk about sub clusters, you may have multiple sub clusters. So depend on how many hop nodes you configure, right? You have 3 hop nodes, that means you may have 3 sub clusters. You have 4 hop nodes, you may have 4 sub clusters, and so on. But
So,
outside, it looks like 1.
so sir, basically all these all the clusters and all the nodes, they're in 1 location.
They could be in the same location or different location. You consider that, you know, they could be on different locations. They don't need to be on 1 location, because there's no connectivity directly between, you know, this hub node and this hub node.
So the network configuration, like do they share the same public and the same IP address, public and private address?
Definitely they cannot.
Yes.
Definitely they cannot. This one will have its own private, as well as the leaf node have a private IP in order to allow the interconnect. Same thing for this one have its own private, and each of the leaf node have their own private in order to allow the interconnect communication and so on. So they cannot share this, they cannot have the same private IP. They may reside on the same subnet, but they may not have the same IP address.
So my last question is, if you want to take like the leaf node from the left, and how would you put it? How would you add it on the leaf node on hop 2?
We have command, right? You have command to do that. You can find command all over the places. Is you
Yeah,
are able to relocate a leaf node from one hop to another hop.
but they don't share the same public addresses.
What do you mean by share the public, the same public? What do you mean by sharing the same public?
I said the same public addresses.
They don't, what do you mean? Of course, they will always have different public IP address.
So so there won't be a problem?
So you touch that they should have, at some point, node we have the same public IP address. Is what you meant?
Yeah, I think like in a one cluster, right, they will share the same, they will have the same public address.
Are you serious?
No.
No, I think even last class I gave a prize to someone here because I was saying that each node have its own public IP address.
So what I'm trying to explain is, I don't know how to put it in terms, but like the first, like let me say, okay, like the hop 1, right, and the leaf node. So the first, almost the first 8 letters, they are almost the same. So just the last 2 will be unique. So my question now is, would this leaf node be able to ping? You just said that this leaf node on hop 1 will not be able to ping the leaf node on hop 2. So how would you migrate it? That was my question.
You have steps to do that. It's possible. You have to know that it's possible to switch one leaf node from one to another one. There are some steps to follow on that. It's possible. Okay, you can relocate a leaf node from one hop node to another hop node. If this hop node doesn't need all the leaf nodes, there are some steps to follow in order to do that. So Oracle already has some customized script that you may need to run in order for it to take effect. It won't be that easy with one command, but there are some steps to follow to locate a leaf node from one to another. So maybe the IP address will be modified, but it's possible to relocate a leaf node from one hop to another one. Okay. I haven't done it right, but based on what I know about it, it's possible. Maybe it's not. I don't know. Right? But I know it's possible. I think I saw it somewhere as well. That is some steps in order to relocate the leaf node. I've seen it somewhere in the past. Another question?
Yes, sir. I have a question concerning the Flex ASM. Yeah, I got distracted a little bit. I don't know if like in each hub node there will be a Flex ASM.
The Flex ASM. The Flex ASM, if you want, you can create it on each hub node, or this same ASM Flex. Mainly, yes, it should be created on each hub node, simply because there is no communication direct communication, right, between the hub node. So to have a better experience, you may need to configure the ASM on each hub node. I cannot tell you about whether the ASM on this hub node will be able to monitor instances on a different hub node. That one I'm not 100% sure, right? Yeah. But most of the time, there will be each hub node will have its own ASM flex configure on it, and it's mandatory. It's not optional. All the ASM instances running on this flex cluster should be flexed, ASM flex. Okay. So you may have an ASM flex on here, another one on hub node 2, another one on hub node N. Okay.
Okay, sir.
Yeah. Any other question? Okay, so as I said, right, I wanted you guys just to grab a small little concept of ASM flex. The remaining part of the slide are just, mainly, these are some other features, but are mainly, you guys will see rack patching method. If you have any question Friday, let me know about it. But the other one is just performance tuning areas, just briefing about performance tuning and the wait event. So this is where I want to stop. And when we come back, it's just for us to practice a little bit before we can proceed and finish everything Friday, if possible. Okay, so let's take a 15-minute break to digest what we learned. And immediately when we come back at 8:15, I will create a database and we are going to play a little bit with the database. So we should cover at least 3 questions. We should at least do these 4 questions, right? And I should show you some other commands. So on Friday, I will try my best to cover as many questions as possible for 4 hours or 3 hours. So that's our last technical session. So I want us to cover as many questions as possible. All right, so see you guys in a moment, okay? We can come back and proceed with technicals. And the steps, I'll just give a different name, right? Because I have, for the morning class, I created a database already called class 26. So I'll call the second one class 26B, so that whenever I'm working the evening class, I use that one, okay? So you guys know that you install the Oracle software and the owner of that software is Oracle user. So you guys know that that user will be the one to create a database, right? So the concept is the same, no difference, okay? You can still call your DBCA, right? As usual. Okay, so it gives you 3 types of databases. You can decide to create a RAC database, or a RAC node database, or a single instance database. So RAC database is what we will be creating. RAC database means the database will be running on multiple nodes, right? And all of them will have a shared storage. And we also have, RAC 1 node. I think I explained the concept of RAC 1 node, right? And I said that RAC 1 node, only one instance is active at a time. So the database will be running on only one instance at a time, not 2. Okay? And single instance is what you guys know as well. Single instance, the difference is that this single instance will be managed by the ASM. So the storage will be the ASM, not the file system, not the regular file system. So what we need is a RAC database, okay? So you click on that. Create a database, you guys know this. I don't need to explain. You guys also know this, okay? We choose general purpose. Okay, this is why it's also interesting. Now you see the type, either admin manage or policy manage. So when it's admin manage, it means that you need to specify the server in which you want a database to run on. So first of all, the database, I will call it plus 26B. Okay, this is the DB name. And if I select only class 1 RAC 1, this database will run only on this node. So if I want it to run on all the nodes, I should select all. So the database will run on class 1 RAC 1 and class 1 RAC 2. If I choose policy manage goes with server pools. So that is why I can decide to create a brand new server pool or use an existing server pool. But you can see here that there is no existing server pool yet, right? So we can create one, right? I can add it as one of the activities later. But this is whenever you want to create a policy management database, you need to create a brand new server pool or use an existing server pool. Okay, the cardinality is just the maximum number of nodes the server pool can have. The pool can have, right? So that's the cardinality. So because we don't have a server pool and I don't want to create a policy manage, so that's why I went with the admin manage. But for practice purpose, you guys can go ahead and create an admin and a policy manage and see how it works, right? So I select all the nodes, make sure you select all the nodes so that the database will be running on all of them. Move to next. We don't have OEM cloud control, okay? So I want to check it. You guys know this, so it's not something new. Put any password you want. Yeah. This is what I was talking about, ASM managing your file for you. So you choose Oracle Manage File, ASM will have control over your files. Okay, you can even multiplex your redo or your control file from here. But if you want to have some control over your files, you can use the common location. And the common location, you have options to choose which disk group, either data or FRA of OCR. We no longer have /ORADATA/ whatever, okay? Those are file systems. So ASM, you have to select on which disk group you want the file to reside on. So we can see that plus data is for data file, FRA is for backups, archive logs, and all those stuff. And OCR is for clusterware configuration file, like OCR and voting disk. So if I'm configuring from data file, I will select data. The size doesn't matter, okay? I chose 3 disks. It's up to you. You guys chose 2. It's fine. The redundancy as well depends on the company, okay? It's not something universal. But Oracle recommends normal redundancy for the OCR, okay? Recommend. So that you have 2 copies, right, of the data. And also, other one can be normal or high, or even external, depending on the level of data security they want, okay? So for my data, I want my data file to go to data, okay? So data plus data. If you want to enable a archive block here, you can do all that here. I will not do it here because I want to do it manually. I want to check it, right? You want to create a sample schema, you guys know that, right? Custom script, if you have an additional script that you want to run after the database creation, you can just add a script somewhere and run it. Okay, so you just need to specify the path of the script. If you have a script located somewhere, okay, you can just add the file name. And once you have it, you click on OK. You come and add the file here. So that script, after the database created, the script will also run after that. Maybe the script is a deployment, application deployment you are performing, or maybe you are enabling automatic backup. Just a script, right, that you want it to run in the database. So you can do that if you want to. And next, all these things, you guys know that. So allocate something reasonable, right? This one depends on you. EMM, whatever, it's up to you. Another interesting thing is the control file. You guys see here the control file is residing on plus data because that is what I selected. You can see here that the first control file will be located under plus data / GBU nickname / control01. The other one will be on the same location, right? But I can change it. If I want the other copy to be on a different disk group, I can just select it. So it means that one copy of the control file will be under plus data, another copy will be under plus FRA. If I don't want them to be on the same location, right? Data files by default are here. You can change the GBU name. And something to pay attention to, right? Online window logs, we have 4 by default, 2 per node. It means that for node 1, we have 2, for node 2, we have 2. And how can we differentiate them? Thread. Now moving forward, if you see thread 1 is node 1, is for node 1, thread 2 is for node 2. Let me take an example. If you want to take a full Alman backup now, which is the RAC, the backup now won't be taken by one node only. Both nodes, all the nodes will take care of the backup. It means that node 1 will back up a certain amount of data, and node 2 will back up a certain amount of data. Okay, so, and to differentiate them, you are going to, the naming convention will be like thread. You will see thread 1, thread 2. Now you can see here, this group 1 is on a thread 1. Group 2 is thread 2, is thread 1 as well. Now, group 3 is thread number 2. Group 4 is thread number 2 as well. If it was a RAC 3 node, we may have group thread number 3. If you have 4 node, we also have thread number 4. Okay? So that's how it is. Once you generate a script, you generate it, it's up to you. And you finish, you have a summary. Okay? Automatic the memory configuration is ASMM. We are using automatic, the ASM is used as a storage type. The database type is administrative managed. You can see here that each instance now will have its own database space. Now you guys should pay attention to naming convention of instances. So if I have a database called class 26B as we have, right, running on 2 nodes, it means that on node 1 it will be class 26B1, on node 2 it will be class 26B2. And you then have that naming convention when you are dealing with administrative managed databases. If it is policy managed database, you will have class 26B_1 plus 26B_2. Okay, that's what makes the difference between an administrative managed instance and a policy managed instance. So you guys can pay attention that for instance 1, a digit that's added to 1. For instance, 2 is B2. And each instance has its own unrootable space, as I was saying. Okay? And you can see the data file allocation. Oracle automatically allocate them because you choose automatic shared memory management. And you guys can see here that this is where my control file will reside. You can see that one copy will be under plus data slash GB rename plus control01. And the other copy will be under GB plus FRA. And you can see that this group, the size is this one. Okay, the size. You can see that group 1, thread 1, group 2, thread 1, and so on. And click on OK. We start the database creation. And that's it for the database creation. Any question?
Mr. Gaza,
Yes.
if you don't have a server pool, you have just go create the database and you go create the server pool, or is other way without not create the database, you go create just the server pool.
You create a server pool first, and then you come and create a database. You attach that server pool to the database.
You need to go create a SQL command, or you need to connect to the DB?
No.
DB.
We talk about a tool, that is SRVCTL tool, that can help you to create all that.
Okay.
So log into class 1, RAC 1. While the database is getting created, you guys now take your time and go over and issue this command. SRVCTL help. It will give you all the options of SRVCTL tool. This tool is a new tool you can use to monitor databases, or to manage databases, manage instances, manage services, manage network as well. And you can use this tool as well to create a server pool, okay? So if I want, for instance, I want to create a server pool, I could help. You can see from here that these are the metrics. Remember, I talked about the pool name, the minimum number of nodes, the maximum number of nodes, the importance. Okay, and I can specify all the servers in which I want the pool to run on. You can see the description of each of them. So this is how you can create a server pool by just using the server control app SRV pool. Okay, and after you create it, you can now attach it to the database on DBCA, because once it's created, right,
yes,
on DBCA you can see that there now.
Okay, thank you so much, Mr. Gata.
Okay, no problem.
Mr. Gaetan,
Yes, sir.
please, can I ask you a question regarding the network related question, the question I postponed.
Go ahead, please.
Okay, you explained last class that basically application connects to the database using a database service, and the database service will take the request and hand it over to the scan listener. Now the scan listener would probably allocate.
One second. It doesn't use database service. It uses the service name. But the service name, right, on your channel or Aura, they have to specify the right service name, right? But the service itself is running on the server.
Okay.
Okay? So you use the service name so that when it gets to the listener, you authenticate it, right? And your connection will be given to the related service. So it's not at it doesn't use the service to connect, but it connects using the service name.
Okay, so the application connect using the service name.
Yes.
Okay. Okay, I correct myself. So after the scan listener authenticate the application,
The
now
scan listener is going to authenticate.
okay, so what does the scan listener do again? I wanted to ask actually that because you said, I quite remember, you said the scan listener would probably, the scan listener will see the service or the node that contain the resources and probably hand the request over to it. Am I correct?
The scan listener, yes, we just forward the connection to the least loaded node if you enable load balancing. Yeah.
So, okay, I wanted to know how would the scan listener know the load that contain the resources or that is least occupied.
Because we have another component called the load balancing advisor. The load balancing advisor, from the architecture, I think you could see the load balancing advisor. That load balancing advisor itself is updated by the pmon of running on each node. Let's take an example. We have 4 nodes. We have these 4 nodes. On each of these nodes, we have database instances. And we all know that the pmon is one of the background processes of a database instance. So that means what? The pmon of the database instance that is running on node 1 will come and update the load balancing advisor about the load on that instance. The pmon that's running on that instance on node 2 will also come and update the load balancing advisor. Same thing for the pmon on node 3 and the pmon on node 4. Now, the scan listener can use those information to identify the least loaded node. So the load balancing advisor is the one to provide those information to the scan listener.
Okay, all right, thank you. That's you've cleared my doubt. Thank you.
You're welcome. All right, so I believe the database creation is done. So let's play a little bit, okay? We'll go a bit deeper next session. Let's play a little bit with this database, okay? So I will open 2 terminals so that I like the bigger screen so that you guys can also. Let me see something. Let me move it. Let me share screen number 2. Which screen are you guys seeing? Okay, you guys are seeing exact data, right? So good. So let me put it here. New session. Then the other session is class 2, okay? Class 1 RAC 2, the second node. And it is I also want to connect to Oracle as Oracle user. Okay. So I don't know how small it is on your screen, but this is the best way I can zoom it. Okay. So this is node 1, this is node 2. Okay. You can just issue hostname -a to see the alias. Okay, that is what you guys use, right? -a to get the alias here. And now these databases are created, right? Because I selected 2 nodes, it means that one instance will run on node 1, another instance will run on node 2. So if I ps grep pmon, I will be able to see the first instance, that is class 26b1, right? And on the other node, I can also see class 26b2. Okay, so this is instance 1, this is instance 2. What you guys see here is what I performed in the morning class. You can see that on each node we have only 1 ASM instance. So this ASM instance, we manage all the database instances on this node. So if this guy goes down, all this guy will not survive. They will not do anything. Same thing for this ASM instance number 2, which is there to monitor all the database instances on this node. Okay. So the database name is class 26B, but that database has 2 instances, class 26B1, class 26B2. Okay. Now the next activity is for us to, next question is for us to show you how to stop and start a RAC database using SRV CTL tool. So the next tool you guys have to learn is SRV CTL tool. This is the best tool to manage RAC databases. Because, see something, if I connect only to class 26B1, okay? Oh, sorry. Sometimes it happens. Sometimes we are tired, we write some crazy stuff. It doesn't even make sense, right? So, you see, what happened is that it's not known, okay? It's not known. Why? Because whenever you create a RAC database, automatically the ORA tab is not updated, okay? So on the ORA tab, the instance is not there. So only the database is registered. So in order for you to be able to connect to an instance locally, you need to add that instance to the ORA tab. So we will add class 26B1 on ORA tab, and we are also going to add class 26B2 on ORA tab. Okay, so you bi/etc/ORA tab, okay, and you add one line for B1. And you save it, right?
Yep.
And same thing, if I cut etc ORA tab here, I will notice that I don't have B2, right? So I may need to add B2. And I save it. So when you do that now, you'll be able to connect to B1 and B2 separately, right? So what is, if you want to connect the way you guys know, right? Here I'm connected only to class 26B1, okay? But if I want to see all the instances from here, I can use the GV dollar. GV dollar gives me the grid view. So it gives you information about all the instances from one location. So it is valid for every other parameter. If you, for instance, V dollar process, whenever you use GV dollar process, it will give you information related to both instances, to all instances. But if you use the V dollar, it will give you details local to that instance only. Okay? So you can see here that the instance is class 26B1. Okay? So now if you are on this instance, you issue shutdown immediate. Only this instance will be shut down, not the database. So this is the limitation, right? So in order to shut down the database, if you want to follow this method, right, you may need to come and shut down this instance, and then you go to the other side, you also shut down the other instance. So you should make sure that all the database instances are down for the database to be down as well. Because by shutting down this instance doesn't automatically shut down the other one. Only this instance will be shut down. Let's take an example. Let's issue, I just issued a shutdown image that you guys are familiar with. Okay. So it is shutting down the database, right? So if you check that instance is not running, right? It's not running. This one is because there's a, I'm just running it from SQL. That's why you have this bash error, but it will go away. So, and you can, if I issue the same command here,
Remove that that hyphen.
why is this? Why is this thing? Why is it crazy? I posted it twice. Okay, let's see. So you can see that the second instance is still running, not affected at all. So you cannot say in this scenario that you shut down a database, right? So this is not how you will shut down a database. Okay. So now the best way to shut down a database will be to use the SRVCTL tool so that you can stop the database, you can stop both instances at the same time or start both at the same time as well. Okay. So the tool is SRVCTL. That's why I want you guys to go ahead and navigate. Okay. A little bit. This is a very important activity. So now let's assume I issue SRVCTL. Okay. The help, if you put help, oh, looks like I'm really tired. So you can see here that it will give you all commands related to database. So if you want to create a new database using the SRVCTL, you can do that. You can create a database manually using SRVCTL tool. You can decide whether you want it to be physical, a primary database or a standby database. And you can see the configuration of the database. That's what we do now. You can start the database using SRVCTL. You can stop the database. You can check the status of the database. If it's, for instance, disabled, you can enable and disable the database so that it's not accessible by anyone. And you can modify a database. Maybe you want to convert it, from a primary to standby, or want to change and use now a server pool if a server was already created, or you want to switch the disk group, you want to change the disk group. Okay, so you can do the modify command. If you want to remove a database from your home, you can remove a database. Okay, if you want to convert a database into a RAC 1 node, a regular RAC into RAC 1 node, you can use this command. Okay, you want to relocate a database from one location to another one, you can use the SRVCTL locate. You want to upgrade database, you can SRVCTL upgrade. You want to downgrade, SRVCTL downgrade. You just need to specify the home in which you want to upgrade to or downgrade to. So let's take an example. The basic one is for you to know how to check the configuration of a database. Okay. So what does it mean by configuration? Let's try. SRVCTL config. If you don't know the entire stuff, right, just put database minus help. I want you guys to be familiar with the help. So the help will give you the command. Basically, this config will tell you that, okay, whenever you use -d, you should specify the database unique name, the DB unique name of database. Whenever you use maybe -v verbose, if you want to help, if maybe you want more information, I never on this one, right? So if you want more detail, you can add -a -v. But the basic one will be just to add this first parameter, like this. SRVCTL, come on. SRVCTL config database -d Whenever you see -D, what follows should be the database name or the database unique name. So it was class 26B. This was the DB name, right? And it will give you the configuration of database. Okay, we give you the DB name, the DB name, the Oracle home, the location of the SP file, which is on the shared storage. That's what I explained. I see that in RAC, the SP file on the shared storage, but the P file is local. So whenever you create a P file from SP file, each node will have its own P file, but the SP file is shared. You can see the type of database, primary. If it's a standby, you see physical standby. You can see on which instance it is running. Don't pay attention to this server pool because this server pool is by default, right? Each database is its own pool, its own server pool by default. So don't see that as another type of server pool. No. You can see here the database instances involved. You can see here that this is the first instance, this is the second instance. You can see that this group plus data plus FRA that this database can use. You don't have any other additional mount point here. If you have a service, you will see the service here. And you can see that it's administrator managed. Okay. So for someone who needs more detail, we maybe put this variable doesn't provide more detail because we don't have a lot of complex configuration. Okay. So that is just to know the configuration, right? If you want to know all the instances, or you want to know the location of the SP file, or you want to know whether it's a primary or standby database, or you want to know whether it's administrative managed or policy managed, the config command can help. You guys can see that just change config by anything you want. SRV CTL status, I just replace config by status, and the remaining part I put it. If you want to stop, you just replace status. You want to start, you just replace status. Okay. So this is just the only one that we change on this database. So you can see the database is running on both nodes. So if I go, I was connected to this instance, right? And I perform a shutdown immediate. By issuing the SRV status, I will have seen here not running. Instead of running, you will see not running. Okay. Let's take an example. I assume that I shut down this instance, right? Only this instance. Let me run again. SRV status database -D. You can see now that the instance B1 that I just shut down is not running on this node, but B2 is still running. It means that user can access the database only through B2. Okay, so that is the easiest way of seeing that. So if you want to start that instance, you have two options. Either you connect again as SQL, you start it, or you can also start it using the SRV command. So if you just put maybe SRV okay, you put instance help, you can see if I want to start an instance and I put SRV start instance and I put help, you can see all the values you need to specify. So because that instance is down, right? I can just, the command say what? SRV I want to start, I always have to specify the database name, okay, which is class 26B. Now I specify the instance name, okay? Which instance do I want to start? It is class 26B1. So minus D is for database, and minus I is for instance. Okay, so by doing this, what's wrong? Let me see. Oh, I forgot to put instance. You guys forgot to tell me, because you should put instance, right? Start instance, SICTL start instance. We forgot this keyword, right? So I put instance here. Okay, and it will start the database instance for me. So you have this option. You can start using the SICTL, or if you want to connect to Secret Plus, you connect as CZBA, like you guys know, and you just start it from there. Okay, you have that option. So this is, for instance, how to start an instance. If you check the status again, you will see that now that the instance is running. If you want to stop the instance, you just replace start by stop. You will stop only that instance. If now you want to stop all the instances at a time, okay, you just need to stop the database. Okay, so SRCTL stop database minus D, the database name. By stopping the database, it will stop all the instances at a time. Okay, so when I do this, it's going to stop all the instances. And if you want to stop, you want to shut down. This is when you do the one like this, it's like a shutdown of all the instances. It shut down normal, a normal shutdown. If you want to shut down immediate, let's assume that you don't even know all these options, right? You put help. We give you all the options, all the stop options. So SICTL stop database. You guys see, you put minus D, the GB unit name, right? Which is class 26B, space. How do you want to stop it? You want to stop normal, transactional, immediate, or abort? You put option O. So they say that option O is to specify which shutdown mode you want. Now you can put immediate. You shut down this database immediate mode. So all the instances will go down. This is the shutdown immediate. Okay.
Nathan, we don't
Yes.
see the bottom of the screen.
You don't see the button?
No.
Sorry. Okay.
All right, thanks.
Okay. Welcome. Let me do the same here.
And quickly, also, what's verbose mean?
Verbose just mean more output.
Okay.
Okay. You need more output because sometimes you have some default output, but if you need more output, verbose will pull more information, provide more information. So if you check now the status of the database, you will see that both instances are not running. This is the best way of shutting down the RAC database, SRVCTL. So if someone asks you how to stop a RAC database, don't talk about shutdown immediate. SRVCTL stop. Okay? And I'll even advise you to know this command. Keep them in your head because as a DBA, you should know if you work in RAC, right? You should have the entire command in your brain. The entire command. So, and how will you have it? How will you keep that in your brain? By practicing, right? So that's why I encourage you to practice. Don't say that it's too easy. Do that. Don't copy and paste. That's why I'm typing. Type. By typing, you okay. You
Sir,
remember that.
we literally have to keep every command in our head.
No. Some basic command like this, like stop an instance, start an instance, stop a database, start a database, check the status of the database, check the status of an instance. It's mandatory. Those are basic commands you should keep in your brain. Yeah.
Okay.
There are some other commands, but it's very basic. You should know. Some other command, they will ask you, if they ask you, for instance, how to create a service. They just want to hear, they just want to make sure that the SRVC shell tool is the tool that will be used to create a service. So you can just say that I will use the SRVC shell. You don't need to tell them the whole command. But if they know that, if at least they know that, okay, you are aware of the SRVC shell tool, that they are good. Because this one is a bit more advanced. You don't create services every day, right? You don't enable transparent application failover every day. But start a database, a RAC database, start an instance, check the configuration, check the status of that instance, check the status of a listener. You should have it on your head. Keep that in your head. So don't stop at the level of configuration, otherwise you will cry. These are basic commands, but this is what people cannot answer in an interview room. So if you issue the same command on the other side, right, you have the same result. Don't think that you have a result here, a different result here. Okay? So -d, database name is class 26B. You see that the result here is the same here. Okay? So we saw how to stop and start a database, and also, okay, let me start it back. Let's have a SQL start database -d, database name, class 26B. Now, depending on how I want to start it, right? Do I want to start it in mount stage? I just want it to be open. I want it to be read only. If you don't know, the -o can still help as well for the start option. So the same -o that helps to shut down images that we specify here, you can use the same -o to start up mount or start up in read-only mode or open. Okay, so it means that I will just specify here -o. If I want to mount it, I will just put mount. Okay, if I want to put in read-only, I just put read-only. As you guys can see here, read-only. Okay, if I want to open it, I don't even need to put -o, because by default, when I put like this, it is open. Okay, so we are going to enable a catalog mode. You guys will see that. So, and by issuing like this, my database is starting. The next session will be more serious, right? And you guys need this basic before we get there Friday. Okay, so it is starting. So all the instances will come up at the same time. If I check the status again, I will see that now database running on both node. So I'm done with question 3 because question 3 was to start an instance. I'll show you how to start an instance. If you want to, for an instance specific, I'll show you how to start an instance. So you should put SRVCTL start, you put instance. For database, you put database. For instance, you put instance. But for an instance, you always have to specify the database name, and you also have to specify the instance name. Okay? Want to stop, you just put SRVCTL stop. Okay? And the last thing we'll be doing now is to enable our catalog mode in RAC. We all have these steps of enabling our catalog mode. We know that we always check the FRA if it's allocated. The next thing we do is what? We mostly shut down image it. I'm talking about single instance high level step, right? We shut down image it. We do what next? Startup mount. Next is what?
Alter database.
Database archive log. I know some people here forgot this, and it's normal. If you are has been a while, you will forget it. And after that, you do alter database. open, right? That's what you guys, those are the steps. So you check the FRA if it's already configured. If not, you will configure it. Then you have to bring down the database, mount it, enable archive lock, and open it, right? So to check the FRA, you can just check the FRA from one instance, okay? You don't need to, there's no SRVCTL command to check the FRA. So you need to be connected to one of the instances, and you issue the same command you are familiar with, okay? So archive lock list, first of all, to know if the database archive lock mode. You can see here, this command is valid for both. So you issue the same archive lock list on the other side. You also see that archive lock mode is disabled as well on. Okay. And you can see there that the sequence is different because they are using different Udilo group. Remember, I talked about thread. So that's why they should not have the same, it's not mandatory for them to have the same sequence. So to check the FRA is the same thing, okay? Show parameter recovery. And it will show you whether the FRA is configured, right? And the size. So you guys know how to add the size ITA system set GB recovery file disk size equal 25 gig. But now, because you have multiple instances, you need to specify SID equal all. So this is to say that you want this parameter to be set on all instances. If you want it to be set only on one instance, you will specify the instance name here. Instead of star, you put the instance name. So when I do like this, if I issue show parameter recovery again, right, you see that it changed here. Let's see if it changed on the other side. It also changed here because I wanted this change to be performed on both instances. So both instances are sharing the same GB recovery. Same thing for the destination. You issue the same command, alter system set, okay, GB recovery file underscore des equal. Here we no longer talk about slash or data slash whatever, right? We talk about this group. So you just need to specify in which this group. Remember we said that the FRA is for the backups, archive lock, and so on. Okay. So, and you also specify SIVCTL equal SID equal all. And you will see now that it is now using the FRA this group. And that will be the same thing for the other one. Okay. So my FRA is set. Okay. So now if I want to enable archive lock mode, you see I need to shut down images, right? My database. But how can I shut down my entire database? I cannot just issue a shutdown image here. I need to exit and SRVCTL stop database, right? So that I can stop my entire database on both instances. Server control. SRVCTL stands for server control. Okay, server control, stop database, -D, you put the database name as 26B. Oh, I forgot to put immediate. You can put immediate so that you will speed up the shutdown, right? That you guys know. The normal shutdown always takes time. But because this database, there is no transaction on it, it will not take that long. Okay? So, but I will recommend you to be shutting down immediate. So you put -O space immediate. And you can check the status, right? If it's really shut down, right? Status database -D plus 26B. The database is down. Instance 1 is not running. Instance 2 is not running. So then I can now just connect. I can do what now? startup mount, right? After we shut down images, the next step is to startup mount. So I can use the same command, srvctl start database -d, database name -o, mount, in order to put a mount stage. And when it is mounted, you can now connect to any of the instances and just add a database archive log, and you come and put it in open, and that's it. So the only difference is that to shut down a database now, you will use the srvctl tool instead of going to each instance and shutting down. Okay, so now I can just issue alter database archive log. And if I exit, I need to put on, because database is mounted, right? It needs to be open. After you enable archive log mode, it has to be open, right? But what happened is that you cannot switch from mount to open directly like that with srvctl. So what happened is you have to stop it again and just start it in open mode. So you cannot switch from mounted to open. So if it's mounted, you stop it, you open it again. Okay, you start it now in open mode. So that means I may need to stop the database again. This is the database name, and I want it to be imaged, right? And this will stop my database again. And I will start it now in open mode, right? So that okay, and just like this, the database will open in read write, okay, and I can connect to each of the instances to validate that. Okay, so once we start it, I will connect back, and we are going to validate whether the database has been in archive log mode. Okay, these are some basic activities, right? You guys should be familiar with. Practice that. So if I connect to the database and I put now archive log list, you can see now that archive is enabled here. If I do the same on this other side, I also see that archive is enabled here. Okay. So now how do they share the job? Let's take multiple data system switch log file. Let's assume there's multiple log switches. You will see that sometimes they share the task, right? One instance we get some logs, another instance we get some logs. Let's perform multiple log switches. Okay, so let's see what happened. If I describe the $v archive log, I can see that one of the basic columns is the name. And you can see that at some point they are sharing. You can see that at some point, thread 1 will take it, node 1, even though here the majority of time, right, node 1 is the one to take it. But you can see that you also have thread 2. You mean that the Hudu log of thread of node 2, the archive log on thread 2 will be used as well. Okay, so you can see here thread 1, thread 2. So now not only one node will be working, will be doing the job, but both will be sharing the activities. Okay, so these are some basic stuff you should master. Play around with this few commands. Next session, we will practice more on, we move to the next question, cluster-ware related, check RAC resources, create a database service, create two services, enable transfer application failover, simulate a crash, check the OCR location, know how to identify a master node, know important cluster-ware log file to troubleshoot any issue in RAC, connect to the ASM and identify all the ASM file location, add a new disk to the disk group and see and monitor the rebalancing, increase the CRS fencing, increase the CSS miscount, convert a single instance to RAC, okay? And upgrade the RAC if you have time. If you don't, I'll give you the document. I'll forward you the link that can help you to upgrade. You can try as well later. So I will stop here. So any question for me? Any question for me, guys? No question? Okay. Either you are tired or you are lost, but there's something going on, right? So
The buffer cache full. We are trying to process it.
I know.
Why do you think we are tired or lost? We might be tired, but we gained something. Why do you think we are lost?
Okay. So my best recommendation for the groups for it to be organized, because you guys have limited servers, I will always recommend you to be doing stuff at the group level first before you move to the individual level. So even for these activities, if you give a server to someone, you tell him or her to perform all these tasks, that person will take even a week to complete it, or 2 weeks. So approach it as a group, right? Work on it as a group. You will learn a lot by explaining to someone else if you know, or by learning from someone who knows. So it's always good to be working as a group on this type of activities. Okay, it makes more sense. So configure as a group and go through this as a group as well. You have enough time with the servers. It's not a rush. You have at least 3 months, 2 to 3 months with the servers. Even if I won't be there, but you guys will still have access to those RAC servers. Your personal server, you have more time with that. So keep on practicing. And my best recommendation, another recommendation, please, even when you get your resume, I hope I will still be around to remind you that never leave your server. But I just gave you 1 month. If some people will spend only a week in the interview room, other people will spend 2 weeks, other 3 weeks, other a month, other 2 months, other 3 months, and other people who are not frequent will spend even a year there. Some people will drop. Don't think that you are done, right? That's where you will see people dropping. People who don't have a strong mental, because they come today, Monday, they come only when they have their own interview. And I always have a, how do we call it? I always have, as a class lead, right? I always have a way of managing this type of people. When you come to the interview, only when you have interview, that is when I take my break as well. That is when everybody will take their break. So you will also take your interview alone. So those type of people that will come, and sometimes they don't come or don't come, they will not improve. Okay? The interview is not for the best. It's far from that. So you see some people who are there, just the consistency will give them a job. Consistency. Coming every day, you can come. If you come every day, that means if every single day you attend one interview, it means that you will learn every day. And you will be lucky enough to have an interview that summarizes everything. You just have to read, right? What you already prepared. So that's another story. I will talk about it when we get to summary, if I'm still available, or even before I release you, we have a discussion about it. Any question you have, we talk about it. Any technique I can provide, when it comes to applications, or when it comes to best companies, when it comes to the best time to apply for a job, or when it comes to references, everything, we talk about it when you get to that time, to that level. So that says we are done for today. So
question.
yes.
Talking about the interview room, with the health condition like the COVID, how is the interview room is managed? Do we have to go?
To tell you the truth, my friend, I don't remember. I don't even know how they are managing it now. Then, but what I'm 100% sure of is that there are still people there. I don't know. That's what 100% sure they are still there. Even your elder brother from class 25, they are there. They just moved. They moved there recently, right? So some of them are going, some of them are not. So they're just taking some precaution, putting masks. I don't even know if they are practicing social distancing or not. I don't know. I cannot tell you anything. But we have multiple rooms. So multiple rooms, not one room. So it means that you can limit the number of people in a room and practice distancing. They have hand sanitizers, they have masks. So that's the best way. That's how they can protect themselves. Because you cannot help your friend to take an interview online. Okay? You cannot. Just some gestures can help, can just provide an answer just using some gesture. Let's assume I'm in a Mr. Koji group. We have been discussing for a year. We have been studying together. So if this Koji just makes some gesture or just give me a hint, I can know what he's talking about because I've been studying with him for a while. So physically makes more sense. And it's better, far better than doing stuff online. So definitely you will figure out. I hope that by then the COVID cases, right, will have dropped and things will come back to the normal, or things will be better than now. Because now the lockdown, limitation, it affected a lot of companies. A lot of companies reduced the team. And that's why if you investigate a little bit, at some point in the interview room, they were struggling a lot to get a job. But now it's opening. A lot of people are getting interviews every single week, every single day, even every 2 days. Because
all right, good news.
Opening back that door. Okay. So anything else for me, guys? Okay, so thank you for your time. Sorry again for coming late, and let's meet on Friday, okay, for the next session.
Thanks, Gaetan.
Okay, sir. Have a good one.
Okay, you too. Thanks.